Welcome to Ask Hilti Continuous Personal Development Training Modules. I'm Selena from Hilti Engineering Team. In this section, you will go through a 40-minute seminar, and in the end of the presentation, you will be asked to complete 5-question quiz. A CPD certificate will be awarded with a successful rate of 60%. In this presentation, we will cover 3 topics. Number 1, we will highlight the hidden risks with inappropriate fire stopping. Number 2 is the test principle of fire resistance. In here, we will emphasize the system test of linear jump and penetration. Number 3, the typical fire stopping application in Hong Kong will be reviewed, and the associated code requirement will be mentioned. The first and the foremost why Hilti committed to fire stopping is to save life. Secondly, fire stopping could help to mitigate property loss by containing fire and smoke within the fire origin. Last but not least, improving building performance is a major concern of all industry. Extensive testing and regulation on additional attributes, for example, acoustic and movement, improve sustainability in maintenance. There are 4 levels of measures to ensure fire safety in buildings: prevention, detection, active suppression system, and passive fire protection. Fire compartmentation is the universal golden rules for architectural design to contain the fire hazard within. Fire stopping at joints and penetrations could not be overlooked, as it helped to reinstate the fire resistance of fire barriers. Fire spread by heating up the material to their burning points. Heat transfer could be achieved by conversion, radiation, and conduction. It is crucial to require the insulation and integrity of a fire barrier to prevent burning of combustible materials in adjacent rooms. When fire happening in one compartment, hot air will build up the pressure, and smoke will spread to adjacent rooms through gaps and penetration. As pointed out by the NFPA Fire Analysis and Research, 3/4 of all fire deaths are caused by smoke inhalation. The visual distance is less than 12 feet during fire. Smoke travels fast in the fire scene, and it was estimated that smoke travels 120 to 420 feet per minute under the fire conditions. Fire compartmentation are enclosed by fire-rated walls and floors. Building surfaces are inevitably penetrated through fire barriers and create the weak points. Therefore, fire stopping is crucial to prevent the fire and smoke spread along the building surfaces. The video of this slide shows proper fire stopping is a must for building fire safety.
Typically, 5 minutes is all you get. Fire, and especially smoke, spread through a building much faster than most people think. Every year, about 3.8 million fires occur worldwide. While damage to assets is in the billions, the yearly death toll amounts to 45,000 persons. Much of this could have been prevented if correctly installed fire protection had been in place.
Architects, planners, engineers, and building owners are responsible for effective fire protection. Oftentimes, they do not realize that fire stop is not an option. It's a clear legal requirement, and negligence or improper execution is a violation of the law. Nearly 60% of fire deaths are not in the room of the fire's origin, and 3/4 of all fire deaths are caused by smoke. When there are through penetrations in walls and floors, toxic smoke easily spreads to adjacent rooms. The keys to effective fire protection are both active protection, such as detectors and sprinklers, but also passive protection. Passive means that penetrations in walls and floors have been sealed with approved fire stop products. This principle is called compartmentation. When installed correctly, fire and smoke won't be able to spread from one compartment to another. This allows for safe evacuation of people and protects valuable assets. The thing about compartmentation and fire protection is it's only as good as the products you use. You know, one always thinks that accidents only happen to other people. That's a false conclusion. It is the responsibility of architects, planners, engineers, and building owners to protect lives and assets by effective and well-designed compartmentation. Hilti offers innovative and legally compliant, internationally approved solutions. We recommend Hilti to be on the safe side.
Given the importance of proper fire stopping, it is essential to understand the technical principles of fire-resistant tests, which reflect the application approach for fire stopping design. Two fire stopping categories will be covered: linear joint and penetration. According to the Clause 5.2 in the 1996 FS Code, compartmentation walls, compartmentation floors, separations, and lobbies should be constructed such that all joints are completely filled with non-combustible materials to prevent the passage of smoke or flame. In comparison, in the FS Code 2011 Clause C 3.2, a fire compartmentation should be enclosed by fire barriers. Protections of all openings, joints, and penetrations located in a fire barrier should have an FRR not less than that of the fire barrier. There is a clear upgrade requirement to use FRR system to seal up all openings and joints located in fire barrier, instead of just non-combustible materials. One example of the non-combustible materials could be cement sand, which was used to completely fill up the joints. However, this may not be a proper FR method, as it has not been fire tested. Fire resistance rating (FRR) means the period of time that a building element is capable of resisting the action of fire when tested in accordance with ISO heating curve. Fire resistance ratings are designated by three terms, where stability, the structural element lost the load-bearing capacity due to fire. Its failure usually causes another structural element to fail. Integrity, the ability to withstand fire exposure on one side without transmission of fire due to the flame or hot gases. Insulation, prevent heat transfer from one side to another. The three terms stability, integrity, and insulation are not required for all kinds of construction elements. For example, floor requires stability, integrity, and insulation, whereas non-load-bearing walls require integrity and insulation. Fire stopping usually requires integrity only and shall be exposed at both sides of the fire barriers. Joint fire stopping start filling minimum wood in the gaps. This provides necessary thermal break between the fire side and non-fire side. After the minimum wood is installed, the fire sealant is spread or crawl to cover the minimum wood, which overlap onto the floor or wall material. The sealant holds the whole system together, attaching the minimum wood onto the substrate. The sealant also plays an important role to stop hot smoke and toxic gases from fire side to non-fire side. This slide explains the difference in the performance between non-compliant products and the test fire stop system when subjected to the cyclic portion of ASTM 1966 testing standard. First, you will see the non-compliant video, which shows drywall mud installed in a joint and exposed to a minimum movement. This video will show that drywall mud cracks and pulls away from the substrate, allowing smoke and toxic gases to pass through the assembly. In the second video, you will see the dramatic difference on the performance on using proper fire stop system under extreme movement conditions.
1/4 to 1/2 inch deflection in the floor at the midpoint. If that joint is sealed with a static joint system instead of a dynamic joint system, the rigid joint materials used are likely to crack, crumble, or fall out over time, which would open the joint to allow movement of fire and smoke. Unless information is available to confirm that a joint is truly static, meaning zero deflection, it is best to use a dynamic joint system.
It is administered to the 500 cycles. This particular test here shows, similar to our UL listing, the 50% compression and extension. And you can note how well the material is adhering to the underside of the metal deck and the gypsum.
This slide shows the different fire stopping solutions for combustible and non-combustible penetrations. For non-combustible penetration, like metal pipe, minimal wood is used to fill up the gaps and play the insulation purpose. Fire stopping sealants will be applied on top to suppress the smoke leakage. For combustible penetration, intumescent materials is needed to fill in the opening formed by the collapse of melting paste. Walls are fire stopped at both sides because fire could be allocated on either side of the wall. Thus, the fire stopping is usually symmetrical. Floors are fire stopped at the underside of slab since hot air brings fire upward. An example of how intumescent fire stopping works. Note that the intumescent inlay within the collar. The reason the collar is necessary is that it must direct the intumescent expansion inward to close the melting pipe. If the collar was not there, the intumescent expansion would take the path of least resistance, which would be straight out into the open space, accomplishing nothing. When we design an effective fire stopping system, we have to consider the characteristics of the base materials, such as the composition of the materials, the thickness of the base, the opening size, and the FR rating requirement. Similarly, for the penetration, we also have to consider their characteristics. Cable tray, insulated paste, and mixed penetration may have variable fire stopping solutions. The video here shows how a fire stopping system is assessed in a fire resistance test in according to BS 476 Part 20 or BSEN 1366. There are some general fire stopping practice for each application. In this section, we will go through the typical applications in Hong Kong and their associated code compliance solutions. In Clause C 10.2, Any voids formed between the curtain wall and the perimeters of the building onto which the curtain wall is fixed should be sealed to form an effective smoke and fire barrier to prevent smoke and fire spread between floors. An FRR of not less than that of the floors. The FRR may follow the test standard suggested in Clause E 12.1, BSEN 1364 Part 4, Fire Resistance Test for Non-Load-Bearing Elements, Curtain Wall Wallings. Smoke leakage test should follow BSEN 12101 Part 1. Traditionally, minimum wool was installed in the gap between slab and curtain wall back panel. A steel plate was attached on top. Under fire, the aluminum framework may buckle, resulting in the creation of a smoke leakage path due to the enlarged gap width. The minimum wool may fall off during fire when it was loose packed or without compression. To form an effective smoke and fire barrier, the fire-stopping system shall provide movement capacity, not only for the cold movement due to wind load, but also for the hot movement under fire. The minimum wool shall be compressed with 25% and fit into the perimeter joints. On top, the joint spray shall form an effective fire smoke barrier. Stick the minimum wool on top and overlap with the concrete edge. The joint spray usually have a movement capacity of 50%. Besides the horizontal joints, the vertical joints between the fire-rated wall and mullion may also be concerned to prevent smoke passing through. Minimum wool of approved density and thickness is placed in the middle of the gap. Joint spray is applied at both sides of the minimum wool. This slide shows the installation method of the joint spray system. Minimum wool of density 60 kg per meter cube is compressed by 25% and friction fit into gaps. Joint spray CFS SPWB is brushed on top of the minimum wool with a web film thickness of 3 mm. Our joint spray shall at least overlap with both edges of the substrate by 15 mm. The acrylic joint spray may take half day to be tap-free. For applications in high humidity conditions, silicone-based joint spray is highly recommended. It is well known that the lift shaft is a vertical shaft enclosed by fire barriers. While it may be easily overlooked, the opening in lift shaft should be properly sealed up with FR system. In accordance to Clause C 9.1, penetration in a lift wall around the frames or rebuilds of landing doors, floor indicator panels, and lift core buttons should be properly sealed to maintain the FRR of the wall and comply with Part E, which means the FRR shall be tested in according to BS or EN standards. Fire stop motor is used to fulfill the gaps between concrete edge and steel frame, with the wooden framework as the supporting. For the control panel and core button, fire stop motor could be applied if the remaining depth is larger than 100 mm in order to achieve FRR 2 hours. For some thin wall cases where the lift shaft wall thickness is less than 150 mm, putty pad is an ideal solution to replace the fire stop motor since it is only 3 mm thick intumescent sheet. It is recommended to stick on the back of control box. The leftmost picture shows the control panel with putty pad at back. Fire stop motor could be used to fill up the gaps or plaster at the back of control panel. We are going to give you an overview on how to select fire stop solutions for typical building surface. The correct selections depends on FR rating, base materials, opening size, penetration type, and so on. It is highly recommended to specify fire stopping type for particular building surface so that it will save a lot of submission and approval work during the construction stage. In Clause C 8.2, every openings for passage of air conditioning ducts, ventilation ducts, electrical trunkings, conduits, pipes, cables, and the like through a fire barrier shall be protected with fire damper or other forms of fire stop to maintain the required FRR of that fire barrier. And in Clause C 8.5, any fire sealing system shall comply with requirement in Part E, which means each fire stopping system shall be tested in according to BS or EN standards. For metal pipes in plumbing and fire service tray, silicone fire stop sealant is usually applied on top of minimal wool. Special attention shall be paid on the gap width and movement capacity if required. Silicone sealant is recommended due to its good weatherproof property and low shrinkage ratio. Plastic pipe have melting point around 200 to 300 degrees Celsius, and they will melt and collapse at the first few minutes of fire test. The fire stop system employed should be intumescent, so that the expansion of graphite-based materials could react upon fire fast enough to close up the holes of melting plastic pipe. Fire stop collar are commonly surface mounted. For the wall case, collar should be installed at both sides of wall. For floor case, collar should be installed at the underside of the slab. If space is limited among pipes, intumescent wrap could be considered to use, as it would flush with the wall surface. One drawback about the wrap is the difficulty of inspection and record. For some inclined and elbow pipes, endless collar is extremely helpful, as it only needs to wrap up 3/4 of the pipe perimeters instead of a full pipe wrapping, as shown in the picture of pipe elbow in the middle. For insulation pipes, for example, refrigerant pipes, condensation pipes, and hot or cold water pipe, intumescent bandage should be used. As the insulation layers could behave as plastic materials, you may use bandage to wrap up individual pipes and put all the pipes into one metal sleeve. This method offers advantage of space saving compared with traditional method where you need to provide individual metal sleeve for each pipe. Fire safety coating is good for medium to large opening, especially having cable tray, chiller water pipes, and multiple penetrations. The fire safety coating CP670 is applied at both sides of minimal wool with density of 160 kg per meter cube. In general, for floor penetration, you need 100 mm thick minimal wool, and for wall penetration, 50 mm thick minimal wool is good for FR 2-hour integrity rating. Please be noted that minimal wool alone is tested against BS 476 Part 4 non-combustibility material test, and this is not the fire resistance test Part 20. You should not simply apply minimal wool as FR system without referring to any fire resistance test details and configuration. For some congested piping area, fire stop block is recommended. Fire stop block is also intumescent material and is soft and flexible. You may easily cut and fit it to the confined area. For the gap around penetration, fire stop foam CFS FFX foam could be used to seal up the gaps. When trunking passing through fire barrier, the openings thus formed inside and outside trunkings should be properly sealed up with FRR system, as data cable bundles are easy to spread fire and smoke. For trunking where frequent repenetration is required, fire stop block offer an easy reinstallation and tidy solution. The cutting-edge fire stop solution for data cable would be speed sleeve, which is a superior for data center and hospital project since airtightness requirement is stringent. You just need twist to open and close the speed sleeve for cable repenetration. Looking for the most convenient solution for small-sized plastic conduits and cables? You may have cable disc. You could simply stick a disc around the penetration. It is a perfect solution for retrofit projects. The socket box embedded in thin fire barrier would be a potential risk if no fire protection provided. The situation could get worse if a group of socket blocks occupy a big opening. In the code of practice, concrete wall of 70 mm and 100 mm could resist fire for 1 hour and 2 hours respectively. Embedment of socket blocks may result in the reduction of fire resistance rating of the wall. Putty pad offers the solution for socket blocks embedded in fire barrier, no matter it is a drywall, block wall, and concrete wall. The putty pad not only offers fire protection, but also provide acoustic insulation for the back-to-back socket box installation. In this slide, we would like to wrap up the content included in the presentation. First, we introduce the concept of fire compartmentation and the crucial rules of fire stopping to maintain the function of fire barriers. Secondly, we explain how a fire test is done, and third, the principles of application approach when design fire stopping. Lastly, the key fire stopping applications in Hong Kong are reviewed. We recommend the most popular code compliance method. You are most welcome to reach our engineer for detailed drawing and test report submission. We have come to the end of the presentation. You can now move to the short multiple choice quiz. If you have further questions, please post on this platform under the Ask tab, and we will get back to you as soon as possible. Thanks for joining us and have a great day.